Alright, the last type of reactions that you're going to have to worry about from the top 5 are combustion reactions. So combustion is when you burn something in the presence of oxygen. And there's kind of 2 different types of combustions. There's ones that are really simple that are also a synthesis reaction. And it's basically when you have an element being burned in oxygen. So this first type is an element burning in oxygen. And you can see here's the example of hydrogen gas plus oxygen gas making water. So you would all know that that's a synthesis reaction, but it's also technically considered a combustion. So, you want to know that, aware that they are technically 2 types, and what you're seeing here is that sometimes it's not as simple as we think it is, and you'll come to find out that sometimes that is the way it is with chemistry. The second type that we're going to look at is burning of fossil fuels. And this is where you burn organic compounds. So right here we have propane. So if you have like a propane tank at your house and maybe you have a fireplace, this is the reaction that's happening. So what happens is you have your organic compound, you burn it in oxygen, and you always makes carbon dioxide and water. So that's something you probably want to underline, star, or whatever, but you always have this product and you always have this product. And here, let me just make a mark. You probably want to make a note of this. What we call this, the burning of fossil fuels, where you make this, is called complete combustion. And again, I'll just write this down. Products are always carbon dioxide and water. And I'll move it so you can actually read it, because that would probably be helpful. If it likes me today. Apparently it doesn't, so I'll just have to move it. Here, we'll just move it down a little. Down below here, let me see if I can just, nope, I can't move that. It's mad at me, it's mad at me. There we go, just so there's more room for you here. Sorry, everything's all messed up now. So if I say complete combustion or I say combustion, this is what we're talking about, the burning of fossil fuels. There is a thing called incomplete combustion, and this is when combustion isn't perfect. So it's typically when you have not so much oxygen. So you can write that down if you want. Typically occurs when there is limited oxygen. You can make carbon monoxide in water as opposed to carbon dioxide in water. And this is when you start getting dangerous, because the carbon monoxide is what can poison you, and your hemoglobin takes it instead of normal oxygen. So this is when you want to be, this is not a good thing. This is why you have carbon monoxide ones. So what you want to just be aware of is the different types of combustion, and then also how to deal with it. Just one thing to be aware of, combustion ones really aren't that bad to write. You just have to be careful when you balance them. So we'll just do 2. In fact, I'll do 1 with you, and then you can try balancing 1. And that's it for combustion. So let's do pentane. So C5H12 plus O2. So this is what it would look like on your test. Now, if you see one of those big organic compounds and it's reacting with oxygen, you know, unless something else, I tell you something weird or something, you know it's going to be combustion. As long as I don't tell you it's incomplete combustion, you can assume complete combustion unless told otherwise. And what that means is it makes it really simple to predict your product, because you always make CO2 and you always make water. Then all you really have to do is balance the equation, and you just have to be careful because they can be a little nasty. So if we balance this equation, we're going to need 5 CO2s. We are going to need 6 waters, and that gives us 16 oxygens on the right side, which means we are going to need 8 O2s on the left side. So these are ones where you typically have bigger coefficients that you just have to worry about. Just one note, if I would tell you it was incomplete combustion, you would use, instead of CO2, you would just have the carbon monoxide, the CO, and water. But that's only if I tell you, so just be aware of that. And just one more with combustion, I'll just give you an example here. Let's do C2H5 OH plus O2. So this is ethanol being burnt in water. Sorry, in oxygen. So I'll pause it again, take a couple seconds. Again, you can assume complete combustion, because I'm not telling you anything otherwise, and then just see if you can balance it. And if you wrote it and balanced it correctly, this is what you would have. You would have 2 CO2s and 3 waters formed, and you would also need 3 oxygens to be burned. Be careful with the balancing, because in this case there is an oxygen and at least 1 oxygen in every single compound, so it makes the balancing a little trickier. If you're not the strongest balancer, you're probably going to need to really practice the combustion balancing. So good luck.